Hey there, let's have a look at this example, exercise 9I question 1j. All right, so we're looking at the derivative with respect to x of the following. Okay, so this looks, from a glance, it kind of looks more like a chain rule problem here. So I would write it down as j. Let's say y is equal to the cos cubed. Okay, so cubed cos of 2x minus pi on 4, and I'm cubing that. Okay, so when I see this problem, the first thing I think about is what's making this difficult. You see, if I isolate it, if I just highlight this section here, I can differentiate a cos function by itself, because I know the rule that when y is equal to the cos of x, then delta y delta x, which is the derivative, is negative sine of x, right? So in my case here, this section I should be able to differentiate. But what's the problem is I have this x cube, or not x cube, but more like I've got this thing cubed that's in the way. So one of the ways, this is a chain rule problem where you combine chain rule with the derivative of circular functions, where you say something like let, I'm going to use u just so that it looks more familiar with chain rule. Let u equal to cos of 2x minus pi on 4. And by saying let u equal to that entire term that I've highlighted, this changes the problem now to y is equal to, instead of cos of 2x minus pi on 4, it is now u cubed. Yeah? Have a think about it. If I replace that entire thing that I've just highlighted with the letter u, or the variable u, then it now becomes y equals u cubed. Now this is something that I can differentiate. This one I'm more familiar with in terms of power rule. I know that delta y delta u, so remember u is a made up variable, this gives me 3 multiplied 2 u to the power of 3 minus 1, which gives me 3u squared. Okay, so that's delta y delta u. Now, because I've introduced a third variable, which is over here, I know I also need to differentiate that as well, because then I can use chain rule. And I'll show you here. We're going to differentiate over here delta u delta x. And I'm assuming that your derivative of, I guess, cosine functions is relatively okay. Then at this point, I know the derivative of cos, I'm going to highlight it, cos itself has to give me sine of the function. So sine of 2x minus pi on 4. Remember, there's going to be a negative to it, right? But one of the things that you need to realize, I'm actually using a chain rule here again, because the rule that I was given is up here. I only have the rule for when it is x, not 2x minus pi on 4. So I'm actually using another chain rule, and I'm actually saying let this entire thing equal to, I don't know, let's make up a variable. Let's say a is equal to 2x minus pi on 4. Okay, and that then changes the problem. I hope I'm not confusing you here, but essentially you're saying cos u is equal to cos of a. And that's why I know that delta u delta a is equal to negative sine of whatever a is. And that's what I have here. True? Have a think about what I just said. I'm saying that negative sine is this negative sign here. A, which is what I've replaced here, is that. Okay, but that's delta u delta a. Remember, you still need to find what delta a delta x is equal to, and that's the derivative of that. And really, this is a constant because that's just a number. Negative pi on 4, if you type in your calculator, it's a number. And we know the derivative of any constant is 0, and the derivative of 2x is 2. So when you multiply them together, because you're trying to find delta u delta x, isn't it? That's what you're trying to find over here. Well, we know through chain rule, delta u delta x is equal to delta u delta a. So introducing a third variable times delta a delta x. You may want to pause every now and then. So here we go. My delta u delta a I've got over here. That's my negative sine of 2x, or just to make it easier for you to understand, I'm just going to keep a there, times delta a delta x, which I found over here before, and that's 2. So putting it together, it is now negative 2 sine of, and since a, we know that a was 2x minus pi on 4, this is my delta u in terms of x, no a's. Okay, so really it's a double chain rule if you really need to think about it, because this is where students get confused. You see, what was the ultimate goal? The ultimate goal was to find delta y, delta x. That's what I wanted to find. I wanted to differentiate that. True? So I started off by introducing a third variable, which is over here. And that helped me differentiate it so I can find delta y, delta u. So remember, this is the same thing as writing delta y, delta u times delta u, delta x. True? I've got delta y, delta u. It's over here. That's my 3u squared. True? So that's my 3u squared multiplied to delta u, delta x. That was what I was doing another chain rule over here, where I found delta u, delta x. But that in order to do that, I had to do chain rule again. Now, normally you don't do it this many steps. I'm just breaking it down to its core so that you can see how I did it. Okay? And then, so now multiplying delta u, delta x, it's multiplying to negative 2 sine of 2x minus pi on 4. So putting them all together, this u value, what was that u? Well, u I defined as cos of 2x minus pi on 4. So you get this, 3 times cos of, what was it again? 2x minus pi on 4. Whoops. Pi on 4, and it's all squared, so cos squared, times negative 2 sine of 2x minus pi on 4. So putting them together, that gives me negative 6 cos squared 2x minus pi on 4 times sine of 2x minus pi on 4. That's my delta y, delta x, and the order could be swapped. Okay, because they're essentially just multiplying each other. It's negative 6 times that, times that. So I can see why J was quite tricky, but I hope that it makes sense. I'm essentially doing a double chain rule if you want to see it in its full detail, but when I do it off my head, I'm already seeing it in a different way. I already see it like this, just to help you understand how I do it fast. It's not really fast, it's just that I'm more proficient at it. How I see it is I see two functions. I see the cube, okay? And I also see a cos function. That's what I'm saying, okay? So when I derive this, in my mind, I start off like this. I say delta y, delta x, and I think, okay, imagine that this did not exist. Okay, so imagine that this did not exist. Then it's something cubed. Then how do you differentiate that? You would say that it would be 3 times something cubed, whatever that is, take away 1. So I already have that in my mind. Okay, so when I write it down, I immediately just simply write this. I write 3 times cos squared of 2x minus pi on 4, because I know I'm going to minus the power of 3 by 1. And then I multiply this with, and I know I need now to find the derivative of cos. Now, derivative of cos is negative sine of whatever's in the brackets, which is 2x minus pi on 4, correct? But you can see that in here I need to do another chain rule, and I know the derivative of 2x is 2.